for now, let me first share the link for others to join. Okay, so I've just written a question here. I wanted to have space where I can solve the question, so that's why I did not get a past paper. But my handwriting is bad. I'm used to typing. All right. And also it's noise today here, so hope I'm audible enough. I'll be shouting. Yeah, so the question says, construct triangle PQR in which PQ is 10 centimeters, QR is 8 centimeters, and PQR is 50 degrees. So let's construct this triangle. Okay, so first we start with the line PQ 10 centimeters. This line PQ 10 centimeters. Okay. Okay, so I'll do it here. Let me just do it on the center. So this is our PQ, 10 centimeters. Okay, so the next point says QR 8 centimeters. So from Q to another point called R. So Q is here. Hope you can see. It's a bit dark, but I hope you can see. Okay, so from Q here to some other points called R, to another point called R, it's 8 centimeters. Okay, and we don't know where R is, but we know this statement here, PQR is 50 degrees. So it means PQ to wherever R is 50 degrees. So we need an angle of 50 degrees. Okay, we need an angle of 50 degrees. Let me just try to adjust my camera. I don't know, the lighting is bad today, so things are appearing a bit dark. But I hope you are able to see. Okay, so okay, so they are saying 50 degrees. So 50, it's here. This is where 50 is. Okay, so you put a dot there, then you get your rule. So we need a distance of 8 centimeters according to this statement. QR is 8 centimeters. Okay, so we need a distance of 8 centimeters. So starting from 0 here, the angle should be such that the line we're going to draw should pass through this point, because this is the 50 degrees angle. The distance we want is, sorry, there was a network issue there. Having lots of challenges today's streaming. So okay, just a second. So our R is here. Okay, so we can connect P and R. Okay, like so, because we know where R is, so we can just connect them. Okay, not perfectly done. I was supposed to position my rule well. Yeah, but like I said last time, I've got the camera and stuff, so my vision somehow not good. Anyway, so here we have the angle 50 degrees. Okay, so this is our triangle. So make sure that your 0 is where P is and your R is I mean, and you take note of where R is. In this case, it's 8 centimeters. Okay, so PR is 8 centimeters. Okay, so just here you can write the question number. It's question A2. Okay, this is question A2, right? A2 is the one that is asking us to measure and write the length. So we're going to say A2. We write PR is equal to 8 centimeters. Okay, can you see? So A2 PR is equal to 8 centimeters. Okay, well, let me just do this. So PR is 8 centimeters. Okay, so write question number and your answer. Okay, so we go to question B. Question B says, within triangle PQR, construct the locus of points which are, so we start with the B1. B1 is saying equidistant from P and Q. I've just remembered that in the last lesson, I was saying equidistance instead of equidistant. Okay, equidistant from P and Q. So we're talking about points that are equidistant from 2 points, point P and point Q. So the points that are equidistant from 2 points must pass. Network is bad, yeah, but we're talking about a line that passes through P and Q on the middle. Okay, how you do that is you stand on P, you do a small arc. Okay, also stand on Q, you do a small arc. So now where your arc meets your line here, okay, where this arc you have done meets PQ, this point, okay, I'm sure you can see the arc there. You can extend the arc, okay, I mean the length. You can extend the length. You do an arc on top and arc on the bottom. Okay, so I've done an arc on top and arc on the bottom. Okay, we also stand here and do the same. Don't change. We stand here and do the same. Let me just, okay, making sure that the two arcs meet, and also on the bottom the two arcs meet. Okay, so now as you can see, our two arcs are meeting here and here. Okay, so now it means the job is done here. All we need to do is to draw a straight line. Now if you read the question B, it's saying within triangle PQR, within triangle PQR. So your construction should just be inside. Okay, so you make sure that the line you're going to draw should pass here and here where the two arcs are meeting, but don't show the parts that are outside the triangle. So this is the line. Once you are done constructing, you write the question number. So this is B1. Okay, next, equidistance from PR and PQ. PR it's a line, PQ it's a line that meet at. Okay, so I'll send PR and PQ meet at P. So where they meet, that's where the line we want to construct will pass. Okay, so we're talking about a line that is that has equal distances from it to PR and from it to PQ. In short, we're talking about the middle of PR and PQ, which is called angular bisector. Okay, because PR and PQ they form an angle here, right? So we're talking about an angular bisector, a line that cuts this angle in half. Okay, so all you have to do, you get your instrument, you stand here, maybe make the length a bit small, so do an arc here and an arc here. Okay, so once you are done, you have to stand where your arc meets the line here, then inside the triangle do an arc. Okay, and also stand here. Okay, inside the triangle do an arc. Where the two arcs meet here, that's where your line should pass. Okay, here. So you get your rule, you make sure that you position a rule such that when you draw a line, it should pass through P and also through where the two arcs meet. Okay, so this is B2. Okay, so B3, 5 centimeters from R. Okay, so R is here, R it's a point, so 5 centimeters from R, we're talking about what's the word? In short, it's a circle. It's like this. You have a point here, then points. So it's a circle like I taught in the last lesson. So all you need to do is you get your tool, then you get your meter rule or your rule, you transfer the distance they have said, in this case 5 centimeters. So transfer 5 centimeters, you get 5 centimeters from here, then you stand on R. Remember this one, points equidistant from a point, so stand on R, then you do an arc within a triangle. Now this is the final answer, so make it a bit dark. Okay, so this is B3. Going to question C, a point T within the triangle. So there's a point called T which is inside the triangle. Okay, so it's saying a point T within the triangle is such that it is 5 centimeters from R. So this point Q, this point T from R, it is 5 centimeters. So the points that are 5 centimeters from R are these. These are points which are 5 centimeters from R. So T must be somewhere on this arc. Okay, and equidistant from P and Q. So again, this point is equidistant from P and Q. So which of these lines represents points that are equidistant from P and Q? Okay, this one represents points that are equidistant from P and Q. This one is points that are equidistant from PR and PQ, but we want equidistant from P and Q. So we're talking about this line. This is the line that represents points that are equidistant from P and Q. So now that T should be along this arc. Again, it should be along this arc. In short, the common region, the intersection, is where the two are meeting here. Okay, so this point is on this, which is 5 centimeters from R, and it is also on this, which is equidistant from P and Q. Therefore, T is this point here. Okay, so you just have to write T. Okay, no need to put the question. D, point X is such that it is more than 5 centimeters. Sorry, point X is such that it is more than or equal to 5 centimeters from R. So we're looking for a point called X. Okay, this point X, it is more or equal to 5 centimeters from R. So we know these are the points that are 5 centimeters from R, meaning that if you pick a point like here, it is less than 5 centimeters, because from R to here, this is 5 centimeters. So this side, it is less than 5 centimeters. This side, it is greater than 5 centimeters. So they are saying this point X, it is more. Okay, so meaning that this point X must be somewhere here. This is the more side, this is the less side, because this is 5, this is R. So from here to here it's 5, meaning from here to here maybe it's 4, from here to here maybe it's 3, just like that. Then from here to here maybe it's 6. Okay, so this area is for points that are more than 5 centimeters from R. Well, this one is for points that are less than 5 centimeters from R. So this point X we're looking for must be somewhere here. Okay, again it says it is closer to Q, or I think here I wrote my own way, it's supposed to be nearer. That's the way they like to use. So it's nearer to Q than P. So again, this point, it's nearer to Q than P. So what is the boundary, or what is the middle of Q and P? It is this line. This line is the middle of P and Q. So they have said this point is closer or nearer to Q than P, meaning that apart from just being here, it should also be this side, not this side. Okay, so it should be this side. Okay, and nearer to PQ than PR. So again, it is nearer to PQ than PR. So PQ and PR, the dividing line is this one. Okay, so they are saying it should be nearer to PQ, meaning this side, than this side. Okay, so the only side, the only region that satisfies that must be this. So you shade it like this. Okay, so this region is greater than 5, it is nearer to Q than P, and also it is nearer to PQ than PR. Though this last point is not anyway, it's okay. I thought it wasn't fully justifiable. Yeah, so let me say that again. This shaded region, this region, as you can see, this is the boundary for 5 centimeters from R. So if you go down, it is less than 5 centimeters from R, right? Then this boundary is for regions, I mean it's a boundary for P and Q, the middle ground of P and Q, meaning that this side it is closer to Q, this side it is closer to P. So X, they said it is closer to Q, so it has to be this side. Again, they said if you compare how far X is to PQ and PR, X is closer to PQ than PR. So the boundary of PQ and PR is this one. Therefore, if it is closer to PQ, it must be below. So this region wins. Okay. Okay, let's look at the most difficult question that I wrote. So I wrote this question in my grade 12. Okay. It's one of those difficult questions that people have said because it's not the common type. Okay, so if you don't fully understand, it can be difficult. Okay, so the question says A1 says construct a parallelogram ABCD in which AB is 8 centimeters, BC 5.3 centimeters, and angle ABC is 60 degrees. Okay, so if you're not sure, try to sketch a small one. Okay, so I'll use this just for sketching, because here I want to put the answer. So they're saying construct a parallelogram ABCD in which AB is going to be 8 centimeters. So we're going to have a line called AB, 8 centimeters. Then also we're going to have BC. So from B to somewhere C, we don't know. It's 5.3 centimeters. But angle ABC, they have given us, it is 60 degrees. Okay, sorry, I was disturbed. Okay, so meaning that A, B, C, we don't know where it is, but they have given us the angle. So once we do a 60 degrees, then we'll be able to tell where C is, since we have the length and the angle. Okay, but this is a quadrilateral and it should have 4 corners. And also we don't know, because it's a quadrilateral, and according to the English here, they are saying it's quadrilateral, or parallelogram A, B, C, D. So it should have 4 points A, B, C, and D, but we don't know where D is. Okay, so what can we do? Okay, the first thing is let's do what we have been given. Okay, so we do AB, which is 8. Okay, let me just use the middle part. So this is AB, 8 centimeters, right? Then also they have told us that angle ABC 60 degrees, so we get our 2, we do 60 degrees. What a noisy day today. So this is 60 degrees here. Okay, so that is 60 degrees. And then they have said BC is, oh, it's noisy. There's a plane passing, so it's noisy. And I'm outside. That's why I'm recording this. Okay. So now they said BC from B to C is 5.3. So we get our meter rule. Okay. So we put it such that when we do a line, it should pass through B and this point which we have marked, which is 60 degrees. Okay, but we stick to 5.3. Sorry, so this is 5.1, 5.2, 5.3. So this is 5.3. I don't know if you can see, it's not that clear. Okay, but somewhere there, that's 5.3. Okay, so this is our C. Okay, so now how do we come up with D? So there are different approach you can use. The keyword is parallelogram. Parallelogram. Okay, I always say parallelogram. It's parallelogram. Interesting. Okay, so so a parallelogram, it's like this. Okay, that is, this side is parallel to this and this side is parallel to this, or sometimes it can be like this. This side is parallel to this side is parallel to this. So even the angles, this angle is, if you extend this line, is equal to this angle. Okay, that's how even this angle, if you extend this line, is equal to this angle. Okay, therefore this angle here should be equal to some angle here, or this line must be parallel to this line. So you can use the approach of parallel lines, which I think is a bit difficult, so it's better use the approach of the angles. So here is 60 degrees, right? So from A to D, okay, in this case, this is our A, this is our B, this is our C, this is our D. So from A to D, from A to D, with this angle here, if we extend this line, this angle is the same as this angle. Okay, so you can just extend the line a bit, this one. Okay, maybe with a faint line. Okay, but you know your A is here. So now the angle from this extension to the line that goes to D is 60. Okay, it is the same as this angle here. Okay, so you measure 60 degrees. So our A is here. Remember, this is just an extension. Okay, it should be faint to help you draw. Okay, so you do this. Oh, sorry, network issues. I can't even remember where I ended. Anyway, I was explaining this method of using the fact that this is 60 degrees So you do an extension, then you do 60 degrees, then you draw a line. Okay, so when you do a 60 degrees like here, so you get your protractor, then you do 60, then after 60 you draw a line. Now that line you're going to draw should be of the same length as BC. Okay, so the length of this one is the same as this one. The length of this one is the same as this one. Therefore, BC and AD are both 5.3. BC is 5.3, so even AD is 5.3. So you can draw a line of 5.3. That's method 1. Method 2, and I think is the easiest, all you have to do is this. A and D are 5.3 centimeters apart because AD is the same as BC, right? So all you do, you get your 2, you transfer 5.3 centimeters to your 2. Okay, there are different approaches, but I think this one is the easiest. Okay, so you stand 5.3. Yeah, that's 5.3. So when you do 5.3, you stand here, you do an arc. Okay, so it's about strategy. Okay, so from A to D it's 5.3, just like the way from B to C is. Again, the distance from C to D is the same as the distance from B to A. The distance from C to D is the same as the distance from B to A, in this case 8 centimeters. Okay, that's what a parallelogram, that's how a parallelogram works. So you transfer 8 centimeters. Okay, so this is 8 centimeters. So stand on C, you're looking for all points that are 8 centimeters from C. Okay, so these are the points. Okay, so now this is 8 centimeters from C, and this is 5.3 centimeters from A. Where the two are meeting, that's where our D is. Okay, therefore this point is our D. So now you can connect our A to our D. And our C to our D. Okay, so this one is like we are given a side, angle, side, a side, and a side. Okay, it is just that the sides were not clearly stated, but by the fact that this is a parallelogram, it means this side and this side are of the same length, and this side and this side are of the same length. So since this is 5.3, you stand here, you look for all points that are 5.3. And since this is 8 centimeters, you stand here, you look for all points that are 8 centimeters. Where the two meet, that's where our D is. So this is our parallelogram. Okay? Hi, I can see you. If you have questions, you can ask. I will do my best to attend to them. Yeah, hope you can see. Go into question B. So question B says, go into question A2. So question A2 says, construct a perpendicular from A. So a perpendicular from A. So they want a perpendicular that comes from A here. Okay. So this perpendicular should meet CD. Okay. The perpendicular should meet CD. Okay. So this perpendicular should meet CD somewhere at a point Q. So wherever this perpendicular is going to meet CD, it should be a point called Q, or we are going to label it as Q. Okay, and write down the length of AQ. So they want us to come up with a perpendicular from here to DC. So remember how to construct a perpendicular line from a point to a line. Okay, so in the previous video, they are, I think we had a triangle like this. Then I said, if you need to construct a perpendicular line that starts from somewhere here and meets this line at whatever point, but it should be at 90 degrees, all you have to do is to stand here, okay? Then you do an arc that's going to cut this line at 2 points. Then again, you stand on one of the points where the arc cuts the line, you do an arc, and again you stand here, you do an arc. So after that, you have to connect where the two arcs meet with the point of origin, okay? Then that is a perpendicular from a point. Okay, so with that, we're going to stand on A. Okay, we stand on A. Let me just position my camera properly. Oh, sorry. Okay, can you see clearly? Yeah, this is better. This is far much better. Okay, so we stand on A. So our aim is to cut CD at 2 points. Okay, so we're going to adjust the length of our 2 here so that it cuts CD at 2 points. Okay, maybe this is good, so it will cut CD here and here. Okay, so it has cut CD here and here. Okay, there are 2 fins, hope you can see, but there is an arc here and here. Next, we stand where the arc cuts CD and do another arc. Okay, I'll make it a bit short and do another arc. Okay, again I'll stand where the arc cuts CD and also do another arc. So the 2 arcs, they meet here, right? So where the 2 arcs meet, we connect this part with A. Okay, like so. Okay, so now we are just showing within the hello. Yeah, so network challenges again. So I ended here. Okay, so I was on question B. On your diagram, draw the locus of points. Draw the locus of points which are, okay, so let me read the question again. On your diagram, draw the locus of points within ABC which are 2.5 centimeters from AB. 2.5 centimeters from AB. Okay, so we're talking about something like this. Okay, remember from the last lesson, if you have a triangle like this, then you want points that are that have an equal distance from AB. Okay, you have to stand here, you do an arc, you stand here, you do arc, you stand in between. So we get our 2, we do 2.5. 2.5, it's this. So we stand on A, stand on B, we do an arc. We stand anywhere in between, we do an arc. We stand anywhere in between, more arcs. More arcs. Okay, so now we connect the tops of the arcs. Okay, but we stick to so this is our answer. This is our B. This is our B1. So 3 centimeters from C. We're talking about points that have an equal distance from a specific point. In this case, the point is C. Okay, so this is simple. we looked it in the last, we looked at it in the previous question. So we just need 3 centimeters, right? So the question is saying 3 centimeters from C. So we stand on C, we do 3 centimeters, but we just show inside. Okay, so this is the final answer. So it should be dark, not faint. Okay, so this is our B2. 3, equidistance from BC and CD. So BC and CD, we're talking about an angular bisector, a line that cuts angle BCD into two equal halves. Okay, so we stand on C, we do an arc that will cut this side and another arc that will cut this side. We stand on the arc, then I'll extend it a bit. We do an arc, and we also stand here, we do an arc. Where the arc meets C, that's where we draw the line. So this line should pass here and should pass through C. Okay, like so. So this is our B3. Finally, P is a point inside ABCD. So there's a point inside ABCD called P, such that P is nearer to BC. So this point P is nearer to BC. So it's nearer to BC, okay, than CD. So it's nearer to BC than CD. So what is the border of BC and CD? It is this line, okay? So meaning that this point we're looking for should be this side, because this is the border and they have said it's nearer to this side than this side, because CD is this side, BC is this side. So it should be somewhere here, okay? Then again, less than or equal to 3 centimeters from C. So this point should be less than or equal to 3 centimeters from C. So which line describes... still having network challenges. So I was explaining the fact that the point P should be 3 centimeters, should be less than or equal to 3 centimeters from C. So this is the border. This is 3 centimeters from C. So if you go this side, it's greater than 3 centimeters. So this side is the side that is less than 3 centimeters. So remember, at first we said the point P should be on this side. Again, because this is the border, so P should also be this side. So it has to be here or here, okay? Not here, because here it's greater, here it's less, here it's less. The job is just to know which of these two regions, this or this. So the question continues. It says it says it is less than or equal to 2.5 centimeters from AB. It is less than or equal to 2.5 centimeters from AB. So which border shows points that are 2.5 centimeters from AB? This one here. This is the one that shows points that are 2.5 centimeters from AB. So now they're saying it is less than or equal to. So AB is here. So from here to here is 2.5. So if you go up, it's more than 2.5. But anything below is less than 2.5. So between these two regions, the one that is below this line, it is this region. Therefore, our P is going to be here. Okay, it means we are done with this question. Okay, so construction is simple. Just have to practice more questions and you will see. This is one of the difficult questions I've seen, and then I think another one was in 2016. I can't recall if it's GCE or internal, but I think it's 2016. But again, it was the same one, the parallelogram. Yeah, the parallelogram. Yeah. Okay, See you in the next lesson.